Hi there, this is your TA Brian Riley, and in this video we're going to talk briefly about diffusion and osmosis. So let's set up a scenario here. I have a container. In the middle of that container I've put this semi-permeable membrane, and on either side of that membrane there are equal concentrations of these little blue molecules. We can call that water if we want to. In this situation, there are equal concentrations on either side of this semi-permeable membrane, and these water molecules are able to pass through this membrane because they're small enough, and as such, you have basically molecules from one side or the other bipping back and forth to the other side at about the same rate. All right, with that in mind, here's a slightly different scenario. I've created the same container with the same semi-permeable membrane, but on one side of the membrane, on the left side of the membrane, I have put these molecules in relatively high concentration, and on the other side, the right side of the membrane, I've put them in relatively low concentration. So go ahead and pause the video and see if you can figure out which way these molecules are generally going to move. If you said that there's going to be a general movement from left to right, from high concentration to low concentration, you're right. Now there are still a few of them that make it back from right to left. For example, this guy right here, he's going back from right to left. But in general, the general flow of these molecules is from left to right. And this continues for a while as these sides try to balance themselves out. It continues flowing from left to right in general. But at some point in time, these molecule concentrations on either side balance out and become equal. And you see this kind of general net non-flow between one side and the other. Maybe one bips over to one side or the other, but in general, there's not really a flow from one side to another. The process of a molecule traveling from a high to low concentration is called diffusion. So here's another slightly more complex situation. I've taken this same box, the same container, and the same semi-permeable membrane, but in this case, I haven't just put these blue water molecules in here. I've put two different solutions on one side versus the other. On this side here, I've put a solution of 95% water and 5% of these orange solutes right here. And on this side over here, I've put a solution that's 5% water and 95% of these solutes. And one thing I want you to notice is that these solutes, for whatever reason, maybe they're too big or maybe they're too polar, they can't make it through this semi-permeable membrane. They just kind of get bounced back off of it. But the water can still go through just fine, right? And in a situation like this, diffusion works just about the same. You have a high water concentration on this side over here, a high water concentration over here, it's 95% water, and a low water concentration on this side over here, it's 5% water. So the water, generally speaking, flows from left to right. Another way of thinking about this is in terms of the concentration of the solute, the things dissolved in this water. And you'll notice that the water is flowing from an area of low solute concentration to an area of high solute concentration, these orange things that are dissolved in the water. Osmosis is simply the diffusion of water from low solute concentrations to high solute concentrations. So this is the end of this video. Thanks for watching, and I hope this has been helpful to you.